world-renowned team of SQL experts. I don't claim to be there myself, but Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, and Jonathan Cahias. I mean, very, very intelligent, sharp people, also extremely friendly. We do instructor-led training. We're actually finishing up in Chicago. I believe next week we have one more class, and then it's on to London, and we'll be in Bellevue, Washington. So we do these internationally as well. We also do online training with Pluralsight. Our consulting business, we do health checks, hardware performance upgrades. We do remote DBA system monitoring and troubleshooting. Speak at conferences such as Past Summit, SQL Intersection. We're privileged to be able to present to so many user groups like yourself. The takeaway here is if you're not currently a SQL Skills Insider, you can go to sqlskills.com/insider. Paul sends out a newsletter about every 2 weeks. That newsletter contains little tidbits from Paul, some personal things, books that he's reading, things that are going on within Paul and Kimberly's life, as well as a technical topic. So we usually cover something related to SQL Server and maybe a professional development thing. And we also include a SQL Skills Insider video. These videos are anywhere from 3 minutes up to about 8 minutes. They're a how-to type topic. We're starting to cover more Azure SQL database topics, SQL Server 2016 features. If we're noticing things that are becoming kind of a hot topic in the SQL Server community, maybe some myths that are going on, we'll quickly record a video and make that available. So you want to make sure to become an insider. We don't share that email list. We don't spam it. It's just strictly an email every couple of weeks on what's going on with SQL Skills. I mentioned our training events. I won't go into much detail here other than we have classes from junior accidental DBA up to the most intense level of performance tuning with our IAPT 01 and 02 classes. Wrapped up today the HADR class. That was one of my favorite. We do BI, SSIS, you name it, we have the classes. So if you're ever able to travel to one of these, you're not going to get any better training. A lot of about me was already stated, so I typically pass over this slide pretty quickly, although the important thing here is my contact information. So tim@sqlskills.com. Feel free to email me any questions. I blog on sqlskills.com as well as my personal blog, although I haven't blogged on my personal blog in about a year. Once joining SQL Skills, writing articles for sqlperformance.com. I'm writing blogs for sqlskills.com. So there's just not enough time in the day to blog at all these sites. I'm also on Twitter. I encourage you, if you're not on Twitter, get on Twitter. There's a huge SQL Server community out there. You can tweet questions to the SQL Help hashtag. There's a hashtag SQL blog. Just lots of sharing. That's how you can connect with the community. That's how you can really start becoming friends with other people all over the world that share your interest in SQL Server. The other kind of takeaway here is, I'm into electronics. I like playing with Arduinos and things like that, although there's, again, not enough time. But I got into farming recently, so I do aquaponics. I have chickens, goats. I raise tilapia, which is a really nice fish. And I just ordered a couple of cows and placed, just asked for a quote on a large tractor. So the whole farming side is becoming real. So if you have questions about farming or aquaponics, feel free to email me about that as well. So I mentioned Pluralsight. The takeaway from this one is if you're not actively a subscriber to Pluralsight, Pluralsight has thousands and thousands of hours worth of training. Just SQL Skills content is over 120 hours worth of SQL Server training. We've actually leveraged the Pluralsight training videos to supplement our immersion event training classes. So where when Paul talks about weights and latches and spin locks, he covers a good portion of it, but he doesn't spend 4.5 hours of the class. He may spend an hour and a half, and then he'll defer to deeper analysis into that topic. Go watch the Pluralsight course. So with that, if you email Paul at sqlskills.com, the subject line include user group Pluralsight code. Paul will send you a no catch, no credit card required code that you can use to register at pluralsight.com and get 30 days of all SQL Skills content. So lots of free training that you can get just by emailing Paul at SQLskills.com. So again, go make up an email address, email Paul, get the code, enjoy 30 days of our additional training. And good stuff. You can pause, go Google or Bing a topic that you weren't familiar with. You can rewind. You can even change the pace. If the talking is too fast, you can slow it down. If it's too slow, you can speed it up. Incredible things you can do with Pluralsight. So enough about all that. We're here to talk about SQL Server backups and SQL Server restores. This whole topic kind of came to life when I was managing a team of database professionals for a very large US-based bank. We're about a $40 billion bank, and I asked my direct reports, how many of you have ever restored a full backup and also then applied transaction logs to it? I didn't get too many hands that went up. I asked about restoring the master database. I asked various questions related to recovering our bank's data, and realized that my team really needed some additional training. So I put together a quick lunch and learn for the team that kind of grew into a session for user groups, then SQL Saturdays, then SQL Intersection and past summits, and other large conferences. And so that's what you're going to that's what we're going to cover now. So what I'm going to cover is, we're going to talk about backup types, how you need to know the different backup types. I'm going to talk about service level agreements and why they matter, which backup types are correct for you, how to know that your backups are actually valid, and then we're going to talk about an approach for backing up large databases. Now, large databases is subjective. How big is a large database? For me, any database that's getting into the hundreds of gigabytes is a large database. Then we're going to kind of shift gears after talking about the types of backups that we can make. We're going to talk about how to restore those backups, how you need to have a restore strategy, how to perform point-in-time restores, and also how to perform piecemeal restores. And all of these things I'm going to demonstrate. Lastly, we're going to talk about having a plan. This means having a solid restore strategy, and then having a proven disaster recovery plan. Notice I have not once stated a backup strategy. You plan the restore strategy, and then that dictates the type of backups that you're actually going to need, which would be your backup plan. So what are the backup types? Hopefully this is not new information to you, other than maybe a couple of the backup types, but we have full backups. That's the ones that we take where we say backup database to disk equals, and we give it a path. A partial backup, that's where you can specify like individual file groups or individual files. A differential, hopefully this one's not new to you. A differential is part of an excellent strategy where you may do a weekly full backup and then a daily differential. The differential is all data that has changed since the last full backup. A full backup resets your differential bitmap, whereas a differential does not reset the differential bitmap. So when you do a full, it's every bit of data in the database, and it resets that bitmap. Differential is just going to be all your data that has changed since your last full, and that differential requires or relies on that full backup in order to restore. So you have to restore a full, then you can restore the differential, and then if you have transaction log backups, you apply those afterwards, and then you're up to the current state. A file group backup, again, that's kind of ties back into your partial. A file level, I don't really see file level in use anymore. That's where you can actually stop the SQL Server service and back up the individual MDFs, NDFs, LDF files. Your log backup, that's your standard transaction log backup. Hopefully for any critical databases that you have, you're doing a full with regular log backups at a regular interval. And copy only. Copy only is a very important term if you're utilizing weekly full with daily differential. Copy only, when you apply that, it does not reset the differential bitmap. So think of this type of scenario. You're doing a weekly full backup, say on Sunday. Monday through Saturday, you're doing differentials. If during the middle of the week, someone takes a full backup and they do not use copy only, that full backup just reset all the differential bitmaps. So let's say that's done on Wednesday. Thursday's differential bitmap, or excuse me, differential backup now belongs to that Wednesday's full backup. If on Friday you're asked to restore production, you go to Sunday's full, Thursday's differential, that differential cannot be restored because it belongs to Wednesday's full backup. Had that Wednesday's full backup been made with copy only, it would not have reset the differential bitmap and would not have interfered with your restore strategy. Now, can you still restore your database? Absolutely. You've already restored Sunday's full. Now you have to apply all the transaction log backups since then. Now, technically, you could restore Tuesday's differential and all logs since Tuesday. So that's why it's important that you use the right backups, you use the right statements when you're doing your backups if you're taking backups outside of your normal backup strategy. This has happened to me in production, and then my question to the DBA that made the midweek full backup was, why did you do this? And they said, well, a developer wanted a copy of production restored down to development. I asked, well, why didn't you restore from the backups we already make on a nightly basis? Why did you have to make a new backup? They scratched their head and said, good point. It's like the data was already backed up. Just restore the weekly full, the differential up to that point. They didn't really need point-in-time data. They just needed fairly recent data. But anyways, so the takeaway from this slide is some combination of the above is warranted to meet your service level agreements, meaning weekly full, daily differential, transaction log backups on a regular interval, or you may be doing daily fulls and then you have transaction log backups occurring at some interval. Now that interval will determine what your potential data loss is. So if you're doing log backups every 15 minutes, then you have a potential of 15 minutes worth of data loss. So I talked about very large databases. So what is very large? Hundreds of gigabytes or more is kind of the standard I go with. Most people think terabyte databases. Well, yes, a terabyte is a large database. However, dealing with backups, if I have several databases that are 250 to 500 gigabytes in size that have 5 to 7 years worth of data, there's a lot of data in there that's never going to change. And I'm backing that same data up. If I'm doing daily fulls, I'm backing up the same stale data over and over and over again every night. So if I can partition this database into multiple file groups, and I put the older data that's never changing into secondary file groups, and if that data is not, if it's not changing, I can now make that file group read-only. Once I back that up, I really don't have to worry about it anymore, as long as I know I can restore from that, that file group level backup. Now you can partition data using partition views, sliding window partitions. You can manually split the data into multiple file groups, which is one of my favorite things to do. But why this is important is it allows for a partial restore, meaning I can restore the active partitions of those file groups much more quickly. So let's think about a terabyte size database. In that terabyte database, I have 7 years worth of data. So roughly 700 or 800 gig of that database is not changing. If I can partition that and only keep the active data, so let's think of a financial system. You typically are only accessing 90 to 120 days worth of data where you're looking up transactions and so forth. Online banking systems, where you're looking at your statements and your balance and things like that. No more than a year's worth of data are you going to really be able to look at. Things older than that, you may have to contact your financial institution. So what if I keep that data in the active file group and I have 200 gig worth of data? If we had a catastrophic failure and I had to restore that terabyte database, I could restore the active partition, the primary file group, in minutes. 200 gig might take me 20 or 30 minutes to restore that. The other 800 gig that would take several hours to restore, I can do whenever. But if I get that primary file group back online, I can restore user functionality and then slowly bring that other 800 gig back online. And I'm going to demonstrate that. But that's the benefit of a partition database. It allows for those partial restores. Every production DBA that's responsible for the backup and recovery, you're responsible for the data, the system, you need to know how to restore transactions. So we have a failure, we have to restore. What do we do at this point? Well, if it's possible, you need to back up the tail log, which is, if I had an audience in front of me, I would say, okay, so show of hands, who knows what the tail end of a transaction log is, or a tail log backup? All right, well, the tail end of a transaction log are all transactions that have occurred since the last transaction log backup. So if we're backing up every 15 minutes, and we just backed up at 12:45 my time, that's what, 11:45 your time. So at 11:45, we just had a transaction log backup. It's 11:48, so we have 3 minutes worth of transactions that could have occurred in this database. That is the tail end of the log. So if you can get access to the database to make that final tail log backup, you want to do so. That way you're not experiencing data loss. So we're able to make a tail log backup. Then we need to restore our last known good full. All right, so we restore the full with no recovery, correct? Then we restore the most recent differential backup. Now you can think of a differential backup as a cumulative log backup. So we restore the most recent differential, and then we restore all the transaction log backups, including the tail of the log backup that we just took. If we can do all of that, we have restored a database with zero data loss, which is fantastic. So the key to all this, you restore the full with no recovery, the differential with no recovery, every log backup with no recovery until either that final log, or once you've restored the final log, still with no recovery, then you can restore database and bring it online. So the tail log, I have a demo that I'm going to do where I show you, even with the most corrupt database, if I have access to the LDF, to the actual log data file, I can restore the tail, or I can back up the tail end of the transaction log. That alone is worth your time giving up this Saturday to watch this presentation, I promise you. And I've also got it on a YouTube video. If you go to timradney.com/tail log restore, it redirects to the YouTube channel with the video. So we've talked about taking backups, we've talked about some various ways of restoring databases, and all of this comes down to having a plan, knowing how to recover your database. Most of us as data professionals, we came into our job, there was somebody before us, we already had processes in place where we're using Ola Hallegren's maintenance solution, we're using Redgate SQL Backup Pro, we're using a database maintenance plan, or somebody has created a custom process of backing up the databases. Regardless of the situation, we have backups that are being made, hopefully. So it's our job, the new people coming into this role, to know how to recover this data. If an event happens and you're responsible for it and you don't know how, that is a career limiting move, meaning you're most likely going to lose your job, and the company, if they didn't have anyone else, could likely fail. Bankruptcy, go under, close the doors because they've lost either clients' data or all of their data. So we need to know how to recover, and you need to be regularly testing that your backups restore. I've worked with clients where coming in, doing an audit of their environment, I find that they have excluded certain backups or databases from being backed up. Come to find out, months prior they were doing some process upgrading of the system, and they wanted to exclude any I/O on that database while they were running these upgrade scripts. So they went into their backup job and put in there where database name not equal to their production database, and then they forgot to go and remove that. Well, their backup job never failed. right? Because they were backing up the system databases and other user databases, but their primary production mission critical database was not backing up. Had they had a process to regularly test and restore their databases, they would have noticed that, oh wow, we can't restore big important database because we don't have backups. You also need a disaster recovery plan. This means something happens to your environment, your data center. There's an explosion, there's a meteor shower, there's a natural disaster, the data center's gone. What do you do now? Are you replicating to another data center? How do you get your databases online there? How do you get all your ETL processes to come online? How do you get applications, your application servers, how are they going to point to the new server? All this needs to be planned and it needs to be tested. Having the data there but never testing it isn't going to work. You need to fully test your recovery plans and do this frequently. If your organization, they might not be able to afford another data center, they may not want to spend the money on that insurance. If that is the case, and this is true, I know it's heavily true in the United States, if that's the case, if you know that if something happened to your data center or the closet that has all of your servers in it and you can't recover somewhere else, have your resume up to date. Because if something does happen, your coworkers that also work with data, they're going to be your competition. So if you can beat them to the market within days because they have to go build a resume, you're much better off. People usually laugh at that, but it's the truth. Another thing is to have your user objects scripted out. If you had to restore your user databases to another server, meaning somebody gives you a new virtual machine or a new physical server, you install SQL Server on it, all your user objects, your users' permissions, the databases they have rights to, all of those things reside in the master database. If you have to restore master, you have to restore to the same minor version of SQL Server. So think about this. SQL Server 2008 R2. We know that's version 10.50. Those last 4 digits, you have to be at that version, that revision, in order to restore the master database. So what is that? 2500 was what? Service Pack 1, 4000 was Service Pack 2, or something like that. It might have been 1600 and so forth, but I think current is like 6000 for the latest Service Pack, and then you have cumulative updates since then. So if you're regularly patching and updating, you're going to have to be at that version revision in order to restore master to get your users back. You can regularly script those out. Microsoft provided a stored procedure, sp_help rev login. It's available at this knowledge base link. Don't worry about trying to screenshot. I'm going to send the group the PDF, or I'll send it to my contacts and they can distribute that out. It's a PDF, so you'll have all the links. But you install the stored procedure, you can schedule that as a job to run and output the results to a file, store that in the same place that you put your backups every night, and let it overwrite that file. And then you have all your users and permissions scripted out. So on the new server, you just run that script and it creates the users and permissions, and then you don't have to worry about restoring the master database. Having this restore validation process in place, so if you're regularly testing your backups by restoring them to another server, a development server, a small virtual machine, it doesn't have to be exactly the same as production with a lot of cores and a lot of memory or fast disk, but you need to restore them somewhere. If you're doing that, you can run reports off MSDB to see how long this takes. And now you know your facts. You know how long your restores would take to restore back to a production environment, and that's kind of critical. If you have a service level agreement that you can only be down for 4 hours, and it's a 600 gig database, and it takes 5 hours to restore, you have a problem. You can't meet that service level agreement, and that 4 hours is from the time of the outage. What if it's a SAN failure or a network failure? If it was a SAN failure and it corrupted your database, and it takes them 2 hours to restore the environment to where you can even get SQL Server back online, but now you find you have a corrupt database, you're already 2 hours into your service level agreement, and you need 5 hours to restore. So now it's a 7-hour outage. Those are the things that you need to be thinking about in planning how you can deal with those types of scenarios. And it may be that, okay, that's a very odd thing that could happen. It's very rare that that would happen, and you agree to accept that additional outage. But think about it, plan it, know your facts, and let's kind of switch gears and start looking at some demos. So hopefully you have a backup or a restore strategy. If not, go plan one. You have a backup plan that can meet your recovery strategy. And last thing on this, and then we'll switch to the demos, I promise. My boss, Paul Randall, when he was still with Microsoft, a client called up and stated that their database was suspect, it was corrupt, they couldn't access it, and they needed help restoring. The database was around 40 terabytes, and they had not taken a full backup in like 4 months, but they had log backups, and the log backups were like every 10 minutes. And so they, Microsoft said, okay, well, let's restore the full database somewhere else. I said, okay, well, somebody's on their way back from the vault that was off-site with the tapes. So they had backed this database up and then stored it on tape and took the tape off-site. Long story short, they were able to restore the full backup, and then all of the log backups, which were months, I mean thousands and thousands of transaction log backups, and this was a bank. It took them like over 3 days to finally restore all the backups, and they essentially had 0 data loss. However, they had been down for 3 days. Most of their clients left the bank. They pulled their money out. They could no longer trust the bank because they were down for that long, and the federal government ended up taking over the bank and selling it off. So the company had planned a backup strategy. We're going to back up. We're going to have our log backups. We're going to store the things off-site. They kind of did all that right. I mean, it was a good plan per se that they could recover, but they didn't plan a restore strategy, meaning they couldn't be down for more than 24 hours. Had they ever tested that plan, they would have realized this isn't going to work for us. We need to keep a copy of the database on site. We need it on faster media, those types of things. We need to log ship to another data center. I mean, something other than being on the slowest media possible, tape, and it being a database that size. So I'm going to bounce out of the PowerPoint. Hopefully everyone can see a SQL Server Management Studio screen. So what we're going to kind of step through first is I'm going to restore my backup sample database from my backup so that I get to a known state. And you can see the syntax here: restore database, database name, from disk, and the path. I'm choosing with no recovery and replace. And then I have a statement, restore database backup sample with recovery. So the default behavior, if you just run restore database, is with recovery. So this final statement, I could just run restore database backup sample, and its default behavior is with recovery. We're going to go ahead and kick this off. And we see that it was successful. I'm going to clear my backup history. This is another thing that if you're not using a third-party tool or scripts such as OLA are not deleting your backup history. I believe database maintenance plans, there's an option in there to check to clear the history and to set the dates. But if you're not using those proven things, if you kind of built your own backup solution, you may not have been aware of the SP delete backup history stored procedure. You pass it a date. So my syntax is I'm passing it tomorrow's date, so it will delete everything in MSDB. For the most part, this would be get date minus 30, 60, or 90. You only want to keep a month up to 3 months worth of backup history. Otherwise, you bloat MSDB, and it can cause performance issues with your backups. So I'm clearing my history. And now I want to show you that the top 10 sales order IDs, we see that our max sales order ID is 75123. Nothing special there. I'm going to perform a full backup and then a transaction log backup. And you can see the difference, backup database and then backup log. So we'll execute these. And now I'm going to step through and insert transactions. So think about in your production environment, if you're doing a log backup every 15 minutes, we're going to insert some data, value 75150. We'll perform a backup, so that was 15 minutes worth of data. We'll add 75200, so another transaction, another log backup, so that's the third backup. We're inserting 75250 with a final log backup. So we'll execute here. And we've now inserted several transactions. We've performed several transaction log backups. And if we take a look at our sales order ID, we see that we did in fact add 75150, 200, and 250. So in this scenario, we're doing nightly fulls, transaction log backups every 15 minutes. What would our restore process be? I mean, what order, which database backups do we need to restore? So we know we need to restore our full, but do I restore the last transaction log backup, or do I have to restore all 4 transaction log backups in the order that they were taken? Now, the time to think about this and step through this for the first time is not in production, right? You need to test these things out. You need to be familiar with this. So what if I told you that I have a script that you can run that will generate your restore sequence? So if we execute the script, it's querying MSDB for the backup set, backup media family, joining on a few things. We execute the script, and it's going to pull back and show me that I need to restore my full backup, each log backup in the sequence that it was made, and then finally a restore database backup sample with no recovery. So each one of these restore statements for the actual files themselves restore with no recovery. And notice that it's using the backup set ID sequence in order to keep these things in the proper order. And then finally the backup set ID, I force a whole bunch of 9, so it's the very last one. So I could literally select this column, copy and paste, run this, and it would restore the database up to its current state. If you take this script and include it into, or you have to make some changes to it, but you could take this as a base script and make some modifications, make this as part of your backup process, and it will generate the restore script every time you make a backup. So you do a full, it will generate, and you'll just have the top line and the last line. You do differentials, which we'll show you in just a moment, or transaction logs. You can write this out to a file, store it the same place as your backup file, and if you ever have to do a backup, all you really need is, if you can take that tail log, you would have that. If you can't, then you at least up to the last transaction log backup. So this is really good to have. All right, so what if we're doing differential backups? How does that change things? So again, I'm restoring to a known state. I'm going to go ahead and clear my backup history again. I'm going to take a full and a log backup just like we did before. And now we're going to step through again, adding transactions, but this time we're going to make a small change. We're adding 75150 and we're backing up the log. So we now have 2 log backups. We're inserting a second record, 75200, but this time we are performing a differential. Now notice the syntax: backup database, backup sample, to disk, give it a path, and I'm specifying with differential. That's the only change that you make to the backup command to change from full to differential. So quite easy. So we're inserting another transaction, 75400, and we're performing another log backup, adding a 4th transaction, and then the 4th and final log backup. So we'll execute this. We just inserted a bunch of data. So now, what sequence would we restore now? We know we at least need the full base. What would we restore next? Well, we have a differential, so that would allow us to skip a couple of log backups. And then we had a couple of log backups after the differential. So I would say it's going to be a full, a diff, and then maybe 2 log backups. But again, I like to keep things simple. If I can have a piece of code that generates the code that I need, that helps me out. So we'll take a look at our restore sequence, and we see that we need our full, then our differential, and then our log 3 and 4, and then the final restore with recovery. So fantastic. If we incorporate this into our backup process, then we're not having to try to figure this thing out at 2 or 3 o'clock in the morning of how to restore our database. So we've covered restoring fulls, we've covered restoring differentials and transaction log backups. So I talked about a piecemeal restore. Hopefully some of you have large databases that you might be able to go back and figure out how to partition. Or you may already have partition databases, but you're not familiar with file level or file group level type backups. So we're going to partition a database and then kind of step through what a piecemeal restore looks like, and doing file group level backups and then restoring individual file groups. So we'll start from a known state, so I'll restore my backup. And what I want to show you here is the actual table itself. So we have data from 2009. We'll scroll through 2010, 11, and then 12. I keep saying this every time I do this demo, but I need to go and update my dates so that this is relevant data. All the 2012 should be 2016 and on down. But the other thing I want to show you here is we have 121,173 rows worth of data. So I'm going to go ahead and do a couple of backups. So I'm going to do a full and then clear my log, because before I can start partitioning and things, I have to have a backup in place. So if we take a look at the backup file group sample database, I'm going to go ahead and refresh. Take a look at some properties. The properties should look very familiar to you. If I click on files, we see we have a primary file group, and then we have our transaction log. I look at file groups, I just have primary. This is probably what you're familiar with seeing if you're not used to looking at partition databases. So, oops, clicked on the wrong thing. So I'm going to alter my database, and I'm going to add 3 additional file groups, 2011, 10, and 9. So I'll execute that, and now I'm going to create files and assign them to their respective file group. So in here, backup file group sample 2009, I'm adding a file to the MDF, to the file group 2009, and so forth with 2010 and 2011. So we'll step through, and we've added those file groups, or the file groups and files. We'll again go back into the properties. We take a look at the files. We see here that we have several additional files. They're auto-growth by 1 meg, and their initial size is 1 meg. That is not best practice, although it is modeled after the model database. If this were real world, you'd want to size accordingly and have proper auto-growth sizes, but we can see the file names here. If we look at file groups, again, we'll see the 2009, 10, and 11 that we just created. Now we need to partition the data. I'm using a partition function. It was real simple to kind of step through within Management Studio. What it's going to do is any data within 2009, we'll put in the 2009 file group, 2010 in the 2010, and same with 2011. So we'll execute that, and let's take a look back at the properties. We'll go to files, and we can see that 2009 has grown to 6 meg, 2 meg for 2010, and 3 for 2011. So we can now physically see that data shifted around in the database. So just in case I blow something up, I'm going to go ahead and do a backup. And here we're going to back up the database, and we're going to specify the individual file groups. This is how you take a file group level backup. You use backup database, your database name, file group equals whichever one you want to back up. So I'm specifying each one individually, so they're going to go into the same file. But I could have just as easily done backup primary to a file, backup file group to another file, or file group 2009 to a file, and so forth. So we'll kick this off, And just so that you can see, we still have all of our data. We still have the same 121,000 rows. You can see that in the very bottom corner. All right, so let's restore just the primary file group. So how do we do that? Restore database, backup file group sample, file group equals primary from disk. But here's the kicker, with partial. This is the only time you'll ever use with partial when you're restoring the primary file group. Once we restore the primary with partial, with telling SQL Server restore just a portion of the database, we're also going to choose with recovery to bring it online, and I'm going to replace the database that's there. So with using with partial, we're able to bring just the primary file group back online. Or we should be able to. Let's hope it works. And it did. So that's really cool. Let's look at the properties of the actual database by querying sysdatabase files. And we'll see that we have the primary file is online, the log is online, but our separate file groups, 2009, 10, and 11, are showing a recovery pending. That means we can still recover them later, but right now they're unavailable. So what happens if we query data greater than 2012? We're able to retrieve 50,234 records. That is really cool. What if we try to query data outside of the primary file group? So we're going to try to query 2009. Of course, we get an error of the index for table DBO cells, gives us the partition ID, resides on a file group 2009 that cannot be accessed because it's offline, restoring, or defunct. This may limit the query result. So that's kind of a cool thing, may limit the query result. That's going to be important. So let's bring 2009 online, and we do this, restore database, database name, file group equals 2009 with recovery. We take a look at the database files again, and we now see that 2009 is in fact online. If we try to query data between January 2nd, 2009 and December 31st, so we're using a boundary between the 2009 time period, we're able to query and we see 43,000 records. So what happens if we try to query we're greater than 2009? Okay, it kind of flashed if you saw it. We saw some query results, but we get the same message about, but now it's the data reside on a file group of 2010 that cannot be accessed. But again, it states that this may limit the query result. Well, let's look at the results. We see the same 43,000 records. So it errored once we got out of that boundary. So if your application allows you to put begin date, end date within the query result, then you could still query this database for data between 2012 and 2009. So that's kind of cool. So here we're going to do between January 2nd, 2009 and December 31st and so forth with 2012, and we query, we get 94,000 records. No errors. So let's go ahead and bring on 2010 and 2011. We take a look. Everything is back online. We'll query for all data, and we have our 121,000 records. You just witnessed partitioning a database and then performing a piecemeal restore. We were able to restore a portion of a database and make it available for users to query against. I mean, that is huge to be able to do that. I mean, if you're dealing with multi-terabyte dating on the active portion of the database, you can do that in minutes versus it taking hours and hours of time. This could be the difference between you having to have multiple terabytes available for log shipping or trying to mirror, or an availability group to have an entire database online, when in reality you really just need a small portion in order to restore your external customer functionality. I mean, this is huge if you can use it. All right, so I kind of teased you about a piecemeal or a hack attach, working with the tail end of a transaction log. This should look familiar, this query. So this is what we generated from our first demo. So we're going to restore the backup sample database to a known state. We'll take a look at the top one sales order ID, and we see it's 75250. We need to insert another transaction, so I'm going to insert 5 nines, 99%. We're going to sales order IDs, and we should see the 75250 and our 5 nines. I'm going to do something kind of crazy. I'm going to set this database offline. So again, we're working with a backup sample database. I'll go into my SQL data folder, data file. This is my MDF. Do you want to delete your primary data file? Not really, but for the purpose of this demo, yes. So we just deleted the data file. Folks, your database can't become more corrupt than not existing. So we'll now try to alter the database, but first I'm going to refresh and show you that our database is showing offline. We try to bring it online. We'll get a nasty message. Unable to open the physical file, SQL data back. If you ever get this in production, my dreadful message to receive. Let's refresh databases. We'll see that we're now in a recovery pending. Y'all have seen this when we did the piecemeal restore. Recovery pending, that's kind of important. That means that we might still be able to do something. So if we attempted our standard backup transaction or backup log database name to an error message, backup sample cannot be opened due to inaccessible files or insufficient memory or disk space, blah, blah, blah. So the database can't be written to. When you do a log backup, it issues a checkpoint. It can't write that to the data file because it doesn't exist. So we're able to use some syntax called no truncate, meaning do not truncate the transaction log. Continue on error. It does several really cool things. And with an it, just in case I've already have this file in place, I want to overwrite. So we back up with no truncate. We just processed 3 pages, folks. This means we just backed up the log file of a database that did not exist. That's big, that's huge. So let's restore the same script above, but this time we're including the tail log that we just took. We'll take a look at our top 2 sales order IDs, and we see that we were able to restore that 5 nines transaction. So I usually like to tell a story, and I've gotten in trouble a couple of times. It's a hypothetical story, meaning it may or may not be true. If you're like me, you've worked with databases that continue to grow. So a particular database grew, and we were running out of storage on the server. So I sent an email over to the storage admin and asked if I could get more space, that we're going to run out very soon. And replied back, sure, no problem, open a ticket, which I did, and was got an email that stated, hey, I have to format a new LUN first, new storage before they could allocate more. A little while later, I start getting a phone call that happened, the application can't connect to the database, then my cell phone rings and it's my storage admin stating, meaning all my data files were gone. Meaning my master.mdf, model.mdf, but yet, well, it's SQL Server. The OS was fine. It was on C drive. I'm able to remote desktop to the server. My data LUN is not there, but I have all my LDFs on another LUN. So I have all the transaction logs, but no data. What would we do then? So we switch over this instance. We take a look. We're going to go ahead and drop the database, and then we're going to pretend that it never existed. We'll take a look in our SQL data folder. There's no backup sample. There's no backup sample log. Okay, so we're in good shape. So I'm on a new server. We still stood up a new SQL server. I need to try to get my tail end of can't on the primary because there's no master. SQL Server service won't start. So what I'm able to do, this is called a hack attach. I'm going to create an empty database, so backup sample. There's no data in backups. We take a look at tables, there's nothing, no user of a database. We're going to alter the database and set it offline. For data sample, we're going to delete backup sample. I'm going to go into my backups. So in this case, production, you're backing up production databases. When you back those databases up, they should be stored somewhere other than your production database server. You shouldn't be backing up to the same physical server or virtual machine. These things need to be going to a network share, to a network appliance like data domain, something like that. So we have our backup files available to us. So if I go into backups, we see that we have our backups, but I'm going to grab the log from a network share, and then I'm going to come over and paste it and overwrite the sample file that we created. So the initial log had no data. This is the one from production, and we try to bring this database back online. So at this point, follow me, we deleted the data file, we copied over our production log file and replaced the sample one created. Now we're going to try to bring the database back online. We get the same nasty message. We refresh databases and we see it's in a recovery pending state. So we're going to run the same syntax we did in the first demo with transaction log. Now at this point, this thinks this transaction log belongs to it. We execute, we just backed up to 3 pages. Now we're going to restore, including our tail log backup that we just made. And so for a server that really was brand new, never seen the backup sample database, we've been able to restore production. This is zero data loss. You just attached a transaction log from one database to another and backed up the tail end of the log. I like to tell people that if you ever have to use this, this is ransom, it's an extra week of vacation, it's a bonus, a promotion. This is the difference in your organization having to tell your customers, we lost your data, versus, hey, sorry for the inconvenience that we were down. This is huge. So hopefully for many of you, this is the first time you've ever seen this. Again, this is on a YouTube video because people like to go and see it again, kind of step back through it. The code is pretty simple, backup log with no truncate. So have fun playing with this one. We're going to switch back over to our primary demo. We'll close out the tail log restore. Also, all these scripts are going to be made available to you as well. They're actually already on my website. If you go to timradney.com, you click on something like sessions or presentations. It's the same stuff I've done in Australia and other places in the world. Just download the zip file and I'll as well. This, if you needed encryption for a tool, or you had to back up to file unencrypted and then use something like 7-zip to then zip up and encrypt your backups. Why are encrypted backups important? Well, if we go through great lengths to protect the data. I mean, we're trying to mask data within a database to limit the users being able to access full account numbers and social security numbers and medical records and things like that. We put databases behind firewalls. We come up with complex passwords. We limit who can view certain data, things like that. But then if you're just doing native SQL Server backups, you're backing up all that data to a file that any system admin that has domain admin, enterprise admin, your storage engineers, anyone that has access to the place that you're storing the backups can take that file and restore it to any server that they want that they've installed Developer Edition to. if it's not encrypted, it's not password protected, all they need is developer edition, the storage. They're already a local, an SA of their developer edition. They restore the databases and they have all the data. So it's important that we start trying to get in the habit and the practice of encrypting our backups. So with SQL Server 2014, how can we do this since it's native and built into the product? First, I need to do some housekeeping and just make sure that I don't have any certificates. Okay, so we've cleaned those up. So first, your SQL Server instance needs to have a master key. You create this by create master key or master key encryption by password, and I'm going to give it a password of SQL Skills @ Next, you need to have a server certificate. With a server certificate, you can give it a name. I'm calling it SQL Skills Encrypt Cert. You can give it a subject if you would like. So we'll create the server certificate. This is the certificate we're going to specify when we encrypt our database backups. So we create the server certificate. Now, before we can use either of these, we have to back them up. So we have to back up the master key to a file, and you encrypt the master key with a password. Same with your server certificate. Before you can start encrypting with it, you have to back it up. Why is this important? Well, if we were to restore this database, this encrypted database, to another instance, we have to have that encryption key or the certificate on that other server. So Microsoft realizes that, and they make you have to back up the key first, or the certificate. If you hadn't backed up the certificate and you lose the server, you lost the certificate, your backups are encrypted with that certificate, you're never restoring those backups. So it's very, very important that when you start using encryption, you have a key management system in place, and then when you encrypt or back up your certificate, you use a password that you can write down and store securely, remember, because if you can't then restore the certificate and decrypt it with this password, again, you have very nice large files encrypted that you can never use. So we've now backed up our master key and we've backed up our certificate. So how do you start then using that to encrypt your backup? So let's look at the syntax. We back up database, backup sample to disk, give it a path with compression, and we're going to specify with encryption. With the encryption, you have to specify your algorithm. We're going to use the AES 256, and then you specify the server certificate. So you can have a different certificate per database, per application set, however you would like to use that. And for here, I'm using compression to show you another quick little demo. Prior technologies, older technologies, if you encrypted the database or you try to encrypt the backup file, it kind of made everything random and you lost the ability to utilize compression, SQL Server encryption. So we're going to back up with compression and using the encryption, and then we're just going to do a standard backup with no compression. So execute those. We stuck both of those in SQL Backup. So let's take a look at SQL Backup. And you can see that our compressed encrypted backup is 4.5 megabytes, and the non-compressed is 15 meg. That's a pretty good compression even with using encryption. All right, so we backed up an encrypted data to encryption. How do we restore this? Since the certificate already exists on this server, we do nothing. We restore database, backup sample from disk with replace. We execute, we successfully restored it. So what happens if the certificate didn't exist? So we'll drop the certificate. We'll now try to restore, and we get a nasty error. Cannot find the server certificate with thumbprint in this really long, unique number or value. So let's create the exact same certificate that we did before. So up here we created a certificate called SQL Skills Encrypt Cert. So down here we're going to create the exact same certificate. So we execute, We now have a certificate. We try to restore using that certificate, and we get a message. Every time you create a certificate, it gets a unique value, a unique thumbprint. So exact same certificate and subject versus unique certificate. Then we're going time from file, original certificate that we created, and we decrypt with the password that we used, complex password. So we create that certificate, and now we restore, and we're in good shape. So backing up with encryption, restoring the encrypted database, as long as the certificate exists, you're just fine. So I had somebody in the audience state, well, what if you're trying to restore to another server? So let's switch over to our other demo box, and we'll take a look at the certificate information. So just like before, I'm going to clear any certificate that might exist. I'm going to create a new master key. This one, I'm calling it new SQL Skills. The master key is kind of irrelevant. You have to have one to manage the keys. So we create new SQL Skills, and now we're going to create the certificate from file. So the backup file that we had created on the other server, we're decrypting it with our password. So we now have created the new key, and then we're just restoring backup file group sample from disk with replace. So we restore, and we just restored that database. So pretty cool stuff. I mean, dealing with the encryption, the most important thing is the key management. You back up the encryption key and have some method of remembering what that password is. Otherwise, you're going to have a server or a database in your backup file that is completely useless to you. You may think, well, we can call Microsoft and they can help us still restore the database. No, they can't. I mean, this is protected. There's no back door. You lose your key management, you lose your encryption key, that certificate, you better have a backup plan for revenue. Good resume, friend at another company where they're looking for a DBA. You have unrecoverable data at that point. So we talked about encryption. What about Azure SQL Database, or Azure Storage? With SQL Server 2012, I believe it was Service Pack 1, Cumulative Update 6, I believe, introduced URL-based backups. This is, a lot of people thought it was a 2014 thing because it came out so late with 2012. With the URL-based backups, we can back up to Azure Blob Storage. Why is this important? You need offsite backups. With this, you can back up the database to Microsoft's data center. Azure Storage is really inexpensive. This is a really slick way to, or easy way to get your backups offsite. Restoring from them, depending on your bandwidth, could potentially be an issue. But where I've seen this be very successful is clients backing up to Azure Storage, and then they have several Azure virtual machines that they have spun up. They can access the blob storage, and they're restoring their backups to an Azure virtual machine. And it's a very small Azure virtual machine from a compute standpoint, but if they ever needed to fail over, it's just switching, checking a few boxes to add quite many more CPUs and more memory to that virtual machine. It's almost seamless. So they're paying for a very small virtual machine, so a few dollars a month. They have the blob storage. They're restoring their databases from it. They have their scripts and everything already built. If they had a catastrophic failure, they switch over to the Azure virtual machine. They scale up in the hardware from like a 2 vCPU, 8 gig of RAM to like an 8 or 16 core, very large box that they need for their workload. And they have a very inexpensive DR plan. So how do you back up to Azure Blob Storage? Well, first you need a credential. So if we go into security and look at credentials, I have Azure Backup. I have the identity, which is my account or the blob storage container in my Azure portal. And then the password is actually keys that I get from the Azure portal. So it's real simple to go in and create a new credential. You give it the name, whatever you want to call it, the identity, which is tied to your blob storage account, and then the keys that they give you. and you create the account. So I'm going to use my Azure backup. I'm going to go ahead and switch the files that we're doing, give them new names. And we're going to back up the backup sample to URL. So instead of to disk, it's to URL. And then we specify with credential, and I'm going to use compression. And then we'll use stats equal 1 so that we can see this kind of stepping through. So it's creating the blank file. We should start seeing it ticking up in just a moment. Usually this takes between 20 to 30 seconds to do the backup, all depending on bandwidth. We see that it jumped very quickly through, and then it should finalize in the 23 seconds. So we just backed up to Azure storage. So what does the restore sequence look like? It's exactly the same restore database backup sample from URL, and then we specify the credential. So we can kick this off, and we're now pulling data back out of Microsoft's data center. I believe I'm using like South Central, although I'm in the Southeast US. So this data center is probably 800 miles from where I'm at. And the restore usually takes a few seconds longer than the actual backup. So we see we're stepping through. We're already at the 23 seconds. Well, it took exactly the same time. So URL-based backups, it's very cool in the technology that how it works. The only thing I do not like about it, if I'm backing up to URL, my databases are in Azure. They're not, or my database backups are in Azure. They're not local in my data center. I would prefer to back up local in my data center first, so I have a copy local, and then push those up to Azure storage. So it's a really, there's a free tool called AZ Copy for Azure Copy that allows you to do exactly that. You back up local, you have this, then when the backup job's finished, you call the AZ Copy through command line, so it's just another step in the job. You pass it the syntax to synchronize the data in these folders or the actual file names that you created, so then it will push that up to Azure for you, with allowing you to keep a local copy in your data center. So think of it like RoboCopy or any of these data synchronization type applications, but this one's free. So check it out, AZ Copy, if you start looking at utilizing Azure Storage and Azure Virtual Machines as a DR plan. So the last demo that I have for you is point-in-time restore. Now, very few people have ever played with actual point-in-time. This means we're going to restore a transaction log, but we want to stop at a certain point within that transaction log. Most people think when we're restoring a database and we're doing log backups every 15 minutes that we have to, when we restore that log backup, if something happened 5 minutes after that, too bad. We can only restore up to that last 15 minutes. When the truth is, you can specify time as well, individual transactions, things like that. So we're going to restore a database to get to a good point. I want to, we're going to take a look. If we do select star from point in time, at this point, we have no data. So if I restore the same database, and I'm going to restore an entire transaction log. So we're stopping here at pointintime.trn. So we restore, and then we take a look at the point in time table. We see that we have 10 transactions, and these transactions are occurring every 30 seconds. So within this transaction log, the last transaction was at 2:11, but I want to stop at 2:09:26. So I want to stop here. So I can specify with stop at and give it the point in time of the actual transaction log. So let's take a look. How does this actually work? How cool is that? So if at 2:09:26 or 2:09:30 or 27 and something, somebody ran that update statement without the where clause and completely made the database useless, unusable because everybody's last name is Radney, not just Tim. The only way you're getting that back is restoring the database and then truncating a table and inserting into, or some manual operation. But what if you can restore and you get up to the minute before that oops situation? You can do that. Now in this case you could restore, and say we wanted to go to 27. So we change that to 27, add some zeros. We restore this, and when we take a look, I guess we didn't go far enough. Let's do 28. Oh, because it's 9. Sorry, folks. This is why you don't type in demos and veer off. So we execute, and now we see that, oh wow, at this time is when things got really bad. This is the transaction that caused all the problems, and we know we can stop at 9:56. So we would then copy that and update, and then could restore and be up to the last transaction that we can find before the bad things happened. This is very crucial to know that you can specify the time within the transaction log to stop at, so that you don't have to take that additional data loss, or you don't have to fight with trying to make sense out of mush data. This is really cool. A lot of people, when you hear point in time, you think just up to the the most recent transaction log. But again, as we have shown here, you can still apply the additional transaction log that has the bad transaction in it and work with it to try to stop just before at that point. So that is really it for the demos. We will switch back over to the PowerPoint, and we have the demo slide. We went on for a while with that. In summary, what we've talked about were knowing your backup types, having the proper backups to meet your customers' service level agreements. That's what it really comes down to. If you're the DBA responsible for being able to manage and support the backup and recovery, it's testing and knowing how to restore from those backups and making sure that the infrastructure you have in place meets those service level agreements. Like I said, if you have a terabyte database with a 4-hour service level agreement, I'm sorry, you're not going to be able to meet that if you lose the database and you have to restore from a full backup. That's going to require some high availability solutions and things like log shipping with a load delay. Because if somebody imports the wrong data or update without the where clause, there's no getting that back without restoring from a backup. If you have a HA solution with clustering, with database mirroring, with an availability group, that transaction is going to roll before you can stop it, and what happened in your productions is happening in the secondary. So with a load delay, you could tell the log shipping, keep it within 24 hours. So if something happened, it's going to take 24 hours before it gets restored to that secondary. So you can now roll those logs up until the point before the accident happened and then fell over. So I don't think anything's ever going to replace log shipping's ability to do that. All the other technologies, I mean, they're async or synchronous. So it's near real time bad things happening. So we covered heavily. I mean, we spent a lot of time in the demos on how to recover from the various backup types. So you need to plan that restore strategy. You need to know how long your restores will take, and you got to know how to perform these point-in-time restores, which we just demoed. So from transaction logs to with stop at. Having that plan. The first time you perform a restore, please don't let it be in production. Test this stuff out. Restore to a development environment, step through the processes, download Developer Edition, take these scripts, AdventureWorks, and just play around with it. know that you have a solid backup strategy that meets the requirements. That helps you sleep at night. That takes the stress out of your job when if something happens and you're asked, hey, can we restore this? You know, sure, no problem. I know that we can because I've validated and I've tested it. And then having that just proven disaster recovery plan in place, just being able to restore the user databases is not enough. If your applications can't connect, you don't have your ETL processes, you need to be backing up MSDB, if file transfers need to be able to still occur. I mean, all those things. Just because you can do your part, but nobody else can do their part, guess what? You're still out of a job. So if you force that, hey, we need to test these things, then you can feel better knowing that if something does happen, your company is going to survive and you continue to have a place to work. So like I've stated before, the demo scripts, timrandy.com/presentations. I already have this out there for a few other user groups that I've done, but I will again upload one because this does have all the demo scripts, and I'll have today's date and the KDSSG listing on it. So I'll get that up in the next few minutes. And with that, I want to say thank you all for attending. I hope you have a fantastic rest of the day and weekend, that you do some fun things. Don't spend all your time playing with the demos, but thank you for having me speak to your group. And if there's any questions, we can either try to field those on the phone or on the webcast, or they can be emailed to me and I can respond that way.